So what I want to do today is review solving linear equations, okay? And we're just going to jump in to solve this first equation. It should be fairly simple for you, okay? And the whole idea about solving linear equations is you want to collect all your x terms on one side and your number terms on the opposite side, okay? All right, so in this case, like we have 12x minus 3 is equal to 9x plus 27. And whatever we do to one side, you have to do to the other side, okay, to keep it balanced, to keep it equals. So I always like to, if possible, move all my x's to the left side. Okay, you probably do too, okay? So what we want to do is here, this is a positive 9x. So we're going to remove the 9x from both sides. Now, you don't need to show me this, okay? But just do the math, okay? So 12x minus 9x would give you 3x. And then minus the 3 is equal to, so there's my equals. This 9x has been removed, so I'm just left with positive 27, so 27, okay? And then I'm going to add 3 to both sides. So adding 3 to both sides gives you 3x is equal to 30. And this 3 next to the x obviously means multiplication. So what we want to do to undo that is to divide, because the opposite of multiplication is division. Okay, so we're going to divide both sides by 3, and that would give us x is equal to 10. Okay, and that's our answer to this first problem. So this next problem, what we want to do is we have solved 7, and this is means multiplication. We have a number next to parentheses. You should know that, okay? And this is a difference in here in the parentheses. It's not just one thing. So what we have to do is we have to distribute the 7. So this becomes 7x, so 7 times x, and then 7 times, and we can think of this as being -6, and 7 times -6 is -42. So we're going to write minus 42 is equal to 28, okay? And then it's just a matter of, this is the only term with x, so we're subtracting 42. So to undo subtracting 42, we're going to add 42 to both sides. You don't need to show me that. You can just do it. So that would be 7x is equivalent to, and then this would be 70. Okay, because 28 plus the 42 will give you 70. And then again, we're multiplying, so we're going to divide both sides by 7, and it gives us x is equal to 10. Okay, and that's all I need you to show me. Okay, all right, so let's go to the next example. So for this problem, we have this this sum right here of -4x and 5 that we're adding together, okay? And we need to multiply that by 2, so that's distributive property. But then we also are subtracting 4x plus 1 from that product right here, okay? So the very first thing we want to do is distribute. So 2 times -4x, that would give us -8x. And 2 times +5 would give us +10. And then we're going to bring down, this is still the -4x, and the plus the 1 is equal to -49. Okay. And now on this left-hand side, before we start moving stuff, we can combine some things. So this is -8x and a -4x, which is going to make -12x. Okay. And then right here, this 10 and the 1 makes 11. So plus 11 is equal to, and then this would be -49. Okay. So now, all right, we have this x term right here. We have a constant right here. And on the right-hand side, we have this minus or -49. So really, we just want to move this +11 over to the other side. So we do that by subtracting 11 from both sides. Okay. And this is -12x is equal to, and then this would be -60, because -49 and then -11 makes -60. And then we would want to divide both sides by -12 to get the x by itself, okay? Because we're multiplying the x by -12. What will undo that is dividing both sides by -12. Dividing this left-hand side by -12 gives us x is equal to, and then -60 divided by -12 would give us a positive, because we're taking a negative divided by a negative. We're going to get a positive, and it would wind up being 5. Okay, so that's example 3. Now let's do example 4. So for this next example, okay, we want to solve 11 is equal to 1/3 times a sum, right? And this sum is the 10x plus the 15, okay? So there's a couple different ways you could approach this problem, okay? I'm going to do it one way. It's just the way I like it. It's just preference on my part, okay? If you wanted to get rid of this fraction first, you could, okay? I'm going to deal with it in a different way, okay? So what I want to do is, if this was just a regular number, we would distribute it. So that's what I want to do. I want to take the approach where I distribute this 1/3, okay? And one thing we need to recall that when we take a fraction and multiply it by a whole number like this, you just take this and multiply by the numerator, okay? So this would be 11 is equal to, so this would be 1/3 times 10x. Well, that'd just be 1 times 10x, which is 10x over 3. Okay. And then plus, okay. And then this one would be 1/3 times 15. So that'd be 1 times 15, which is 15 over 3. Now, some of you might be thinking, well, and it's okay if you do or if you don't. Some of you may be thinking, oh, this is 5, right? And yes, absolutely, because 15 over 3 is the same as 5. So if you wrote 5 here, you would not be wrong, okay? So now what I want to show you, and you're going to be dealing with this in Math 3, is how do you clear out all these fractions, okay? So one way to do that is to whatever you do to one side of the equation, so this is the left side, this 11, this sum right here is the right-hand side. Whatever you do to one side, you have to do to the other side. So what I'm going to do is I'm going to multiply the left side by 3, and I'm going to show that to you. So this would be 3 times the 11, and then that's equal to this 3, and then times 10x over 3 plus 15 over 3. All right. Now, what we have to do on this side is this is distributive property again, right? So this left-hand side becomes 3 times 11, which is 33, is equal to, and then this one becomes 3 times 10x over 3. Now, I'm not going to actually multiply. I'm going to write it as 3, and I'm going to put a dot for multiplication, times 10x over 3. And then plus, and then same thing here. This is going to be 3 times 15 over 3. Now, the reason I'm not actually multiplying out is because this is going to make that big 1, that's giant 1, right? Because we have 3 over 3. So this 3 and this 3 cancels. This 3 and this 3 cancels. And so these make 1. Let me actually circle that. This, and this. Because we're multiplying, this makes a 1. And this makes a 1. So what we're left with is 33 is equal to 10x plus 15. Okay. And now the next thing is I'm going to keep this x on the right hand side. Okay. Because that's the only term that has x. This is the number and this is the number. So I'm going to subtract 15 from both sides. Okay. And 33 minus 15 would give me 18 is equal to 10x. And then dividing both sides by 10, okay, we would get 1.8 is equal to x, okay? And let me slide that up so you can see it. So right here, we divide both sides by 10 and we get 1.8 equals x. We're gonna write our answers in this class as decimals, okay? Because everything that we do in physics is measurements, okay? So this is gonna be related to some type of measurement, okay? All right, let's go to the next problem. So for this example, on example 5, we want to solve this equation, okay? And this equation involves fractions, okay? So we have a fraction right here, and the denominator is 3. And that also means we're dividing this little piece right here by 3. So we're going to need to multiply by 3 to cancel out that 3, okay? Now, we're also adding this other fraction that has a denominator of 12. So this one we're dividing by 12. So what we want to be able to do is pick a number that 3 and 12 will go into, okay? Because those are our two denominators, so we're going to want to multiply by that. Now, one way to do this, okay, is just start with the smallest denominator and start listing them. Look at multiples of that. So like 3, and then 6, and then 9. So Does 3 go into 3? Yes. Does 12 go into 3? No. So we don't want to use 3. Does 3 go into this 6? Yeah, it goes in twice, right? But 12 doesn't go into 6, okay? How about 9? Yeah, 3 goes into 9. But does 12 go into 9? No. So the next multiple of 3 would be 12. Does 3 go into 12? Yes. Does 12 go into 12? Yes, once. So that's what we want to do. So we want to take this equation, and what we want to do is we want to multiply both sides by the number 12, and I need to get my other pin, okay? So I'm going to show that. Okay, so right here's my equals, so I'm going to want to multiply this entire left side by 12. Okay, so then we'd have 2x minus 4 over 3. Hold on. I put a parenthesis there and I wish I hadn't. Okay, so now all of a sudden that parenthesis is gone, right? And then so I want to put in also plus x plus 7 over 12 and then close the parenthesis. Then this is equal to, and then here I'm multiplying this right hand side by 12 and then in parentheses the negative 9. We'd want to put parentheses there and just not leave it minus 9 because then it looks like a subtraction problem, okay? So right here, now this 12, we're multiplying by a sum. It's a sum of 2 fractions. So this is distributive property with 2 fractions. So this 12 gets distributed with this first fraction and it becomes 12 times 2x minus 4 over 3 plus 12 times x plus 7 all over 12 is equal to 12 times negative 9, okay? And then that would be negative 108. And you would use a calculator for that, okay? Now, why didn't I distribute this 12? Because you could have, okay? But here's why I didn't. This 3 is going to go into the 12 how many times? So I'm going to cross the 3 out, and it goes into 12 4 times. And this 12 goes into 12 1 time. So this becomes 4 times 2x minus 4 plus 1 times x plus 7 is equal to negative 108. Okay, so now it looks like a problem we just did earlier, right? So all we're going to do next is we're going to distribute this 4. So it becomes 8x minus 16. And then plus, and then we distribute this 1, it just becomes plus x plus 7 is equal to negative 108. And this 8x and this x can combine and make 9x. And the negative 16 and the positive 7 combines to make negative 9 is equal to negative 108. And then I'm going to add 9 to this left side and also the right side. And that would result in 9x is equal to negative 99. And now because I'm multiplying this x by 9, to undo that, I'm going to divide. So divide both sides by 9, and the result would be x is equal to negative 11. And that's, let me slide that up a little bit. So that would be x is equal to negative 11. And that's the answer to this problem. Okay. Now, I'm kind of doing this to see where you guys are out with your solving abilities. Okay. So this is a more difficult one. Okay. And I just want to see where you're at. It's kind of helped me when I do this assignment to know, okay, where everybody's at in their math, okay? Some of you guys are this is gonna come easier than others. I know that. Don't worry about it, okay, too much at this point, okay? I just want to see where you're at, all right? So let's go to the next example. So for this next example, okay, we have actually 3 denominators, right, that we want to get rid of because there's a denominator here of 8, and then we're subtracting here. And here we have a denominator of 6, and here we have a denominator of 24, okay? So, okay, so what do we want to multiply both sides of this equal sign in order to cancel all of these out? Some of you know it right away. Some of you guys will need a little bit more work. That's okay, all right? So let's take the smallest of these denominators, which is 6, and let's start looking at multiples, okay? So 6 isn't going to work because 8 doesn't go into 6, and 24 doesn't go into 6. Okay, so what's the next multiple of 6? Well, it'd be 12. Does 8 go into 12? No. Okay, so it wouldn't be 12. That's not what we want to multiply by. What's the next multiple of 6? It would be 18. does 8, this 8 right here, does it go into 18? Because then we're going to be able to cancel if it does. Well, it doesn't, right? Okay, so what's the next multiple of 6? Well, 24. Does 8 go into 24? Yeah, 3 times. Does 6 go into 24? Yeah, 4 times. Does 24 go into 24? Yeah, once. So what we can do is multiply both sides by 24, and that's going to clear out each of these fractions, okay? So what I want to do is I want to multiply by 24, okay? And then this would be negative 9 over 8, and then minus x plus 5 over 6. I'm going to close the parenthesis. If you don't put the parenthesis, you're not multiplying the whole side by 24, okay? And then this is equal to, and then 24 times the 1, okay? Now, because this is a difference of two things, I'm going to need to distribute this 24 with both of these fractions, okay? So this becomes 24 times negative 9 over 8. I actually don't want to multiply it because this 8 is going to go in, okay? And then minus, and then 24 times x plus 5 over 6 is equal to, and then 24 times 1, that's just 24, okay? So why didn't I multiply this 24? It's because this 8 is going to go into 24. Oh, you know what? I forgot. I am sorry. Let's back up a little bit. That wasn't 1. That was actually 1 over 24. I think in my head I had already canceled it out. Okay, so this would be 24 over 24. Sorry about that. Okay. All right, so back over here. Why are we doing this? Because this 8 goes into 24 3 times. So we can cross the 8 out and we can put a 3. And this 6 goes into 24 4 times. And this 24 over 24, well, that makes just the giant 1, right? So what we have now is 3 times negative 9 minus 4 times x plus 5 equals, and then this would just be 1. And from here, it's going to be a fairly straightforward problem now, okay? So 3 times negative 9 is negative 27. Negative 4 times x is negative 4x. Negative 4 times 5 is negative 20 is equal to 1, okay? So this negative 27 and this negative 20 we can combine. So negative 4x minus 47 is equal to 1. Because I'm subtracting 47, I want to add 47 to both sides, and I get negative 4x is equal to 48. And then because I'm multiplying by negative 4, I want to multiply, or sorry, not multiply. I want to divide both sides by negative 4, and that would give me x is equal to negative 12. Okay, so we do have to have some ability to solve for this class. Now, to be honest with you, we probably won't have any equations that are this difficult in this class in physics. I'm just kind of seeing where we're at, okay? So I want to emphasize that. I'm just kind of seeing where we're at with algebra so I understand kind of where I need to help you out and where you're okay and I don't really need to talk more about it, okay? All right, guys, that is all, okay?